All right, so this is a very nice little question that we have here. Okay, all right. So let's go over this. So, yeah. An audit of a banking transaction system has found that on an earlier occasion, two joint holders of account A attempted simultaneous transfers of rupees 10,000 each from account A to account B. So let's like try to make a very simple sort of a diagram here. So they are trying to send essentially, they are parallelly trying to send amount to B, each of 10k. That's great. They are trying to do that. Both transactions read the same value of 11k. The initial as the initial balance of A. So the initial balance of A was 11,000. Both of the joint account holders thought that they had 10,000 and they sent it. And what happened was, it was allowed. Oh my god. And B was credited 10,000 twice. So it got 10k and 10k. So now it actually has 20k. Amazing. A was debited only once and ended up with a balance of 1,000. So A now has 1k, but it technically added 20k to B's bank account. That is what is essentially happening here. So again, let's just understand what has happened. So there were two people who were having access to joint like one account. That's completely fine. And then there's account B. Fine. Now both of these users, let's say they are in two different countries, states, whatever, they did not communicate, they're somewhere, whatever it is, right? The account had 11k as the balance, right? And what happened then was that, as let's say holder 1 did the transaction of 10k, holder 2 also initiated the transaction of 10k, and what happened was the banking system somehow screwed up or something happened, and they both thought that they had 11k. So H1 looked at one copy of 11k, H2 looked at one copy of 11k, and they just initiated the transaction, and B was transferred 20k essentially, and the account A ended up with 1k as the balance. Now notice that this does not add up, right? So let's say that I want to make sure that some things here are just very clear. So initially A had 11k, let's say B had 0. So if you subtract 10k, right, and if you end up with basically let's say 1k, right, they should technically have had 10k, right? This is what should have happened, but what has happened is they transferred 10k, and now B has ended up with 20k, right? That is basically what the problem is here. So the bank has basically failed in performing a check, okay, and it basically performed double debit, and it even gave the amount to B while not even caring if A actually had 21k or not, right? Basically A should have had 21k to enable this kind of a transaction, but the bank did not check it. So now they are simply asking which of the following properties are certain to have been violated by the system. So now let's go over each of these property, because I'm making this to essentially review what ACID really means. So A stands for atomicity, right? As the option is, I'm not going to write it, right? What does atomicity mean? Atomicity means that when you are basically doing a particular transaction, the transaction is not interrupted at all. So for example, right, so or let me actually rephrase that and explain it properly. So let us say I have P and Q. Let's say P is sending 1 unit of something, let's say 1 rupee to Q. So what happens is, to ensure that there's atomicity in the system, there's only two possible cases. There's only two possible cases. Either P will send the 1 to Q, or P will not be able to send 1 to Q. What that means is, either this transaction will succeed or it will fail. If it succeeds, what will happen is that P will lose 1 and Q will gain 1, right? And if it fails, let's say there's some network issue or some nonsense like that, this 1 rupee that they had sent in the system will not float around anywhere. It will in fact come back to P. So so basically what atomicity then points at is, you either fail the transaction or you succeed. There is no in between. There is nothing. Okay, the transactions cannot be interrupted. No one can come and pop in here and try to be like, hey yo, please stop for me, I have to send a packet, or no, none of that. The transaction happens and it either fails or it succeeds. If it fails, things are rolled back and the P and Q will have their original balances. If it succeeds, then P will have some amount reduced from it and Q will gain some amount. Basically that is what is supposed to happen. Now if you think about it, were there transactions interrupted in any way, shape or form? No, both of them were allowed to perform their transactions, right? And a debit kind of thing also happened, 10 minus 10k and all that kind of stuff happened. So to both of them, it does seem like their transactions actually did happen in an uninterrupted and an atomic fashion. So therefore, atomicity was not violated. Atomicity was actually followed here, right? Which probably it shouldn't have had. There's much more checks here that should have been done, but okay. Now I won't directly go to consistency and isolation. First we'll cover durability. Now durability is a very simple idea which simply states that once you perform this transaction, so it builds upon atomicity. The idea is that if you succeed, and once you store this inside like a database, right? If you store it inside a database, wow, that is a jank looking database, but once you have stored it inside a database, that it is permanent. No matter what, even if the heat death of the universe happens, this information of this particular transaction will exist. And if you look at it, the transactions were definitely not deleted. They still exist in the system. Therefore durability was actually followed and certainly is not being violated. So A and D are definitely not the answers at all. Okay, and this is a multiple select, I think, but we'll find out through the definitions. Okay, so consistency. What is consistency? Consistency, right? Consistency simply refers to the idea that when a particular value is read, like that is how you might think of it, right? Because generally that is what we think about, right? Like cache coherency and all that, values have to be consistent in caches. Here the idea is kind of like little bit different. So look, if I'm running a bank and if A wants to send to B 10k, what is the first, second and third things that you will check? Literally the first thing that you will check is that if this transaction has to happen, A must and should have 10k. If they do not have 10k, they cannot give 10k. They just don't have the money. That is the first thing that you will check. After the transaction happens, let's say, the literal next thing that you will do is that for A, the balance now must be minus 10k, and for B, the balance must now be plus 10k. And of course, if you sum these up, you'll get 0. Like that's the point, right? Energy is neither conserved nor destroyed. Similarly, the amount is neither created nor destroyed. It remains constant. It just passes through, changes its form or whatever nonsense. That's the idea. So notice the idea of consistency is that certain basic rules of engagement has to be followed. So literally at the first point, this guy must have the money to send. Right? This guy must have the money to send. And once the money is sent, it must reflect that, okay, mine 10k has been lost. Okay, this guy has gained 10k. Notice what has happened in our beautiful little example here. This moron had 11k, but somehow it has credited 20k. Is that consistent in any way, shape or form? That is incredible. So you're losing 11k, but you are ending up with 20k. That is some incredible levels of money laundering, or I don't know what is happening here. Money creation, I don't know what's going on. So clearly consistency was utterly ignored. Therefore consistency has been violated here, right? They did not perform any rule checking, anything like this. Is a very weird database system, and yeah, that was a failure. Let's look at isolation as well. So what does isolation actually represent? Now this is a very cool idea which I actually kind of missed out when I was initially solving this question. The idea of isolation is that each of these transactions can be run on their own, right? That is how you might initially interpret it, right? So let me kind of write it like this, right? So let us say A was trying to send 10k. A was trying to send 10k, right, to B. B, C, doesn't really matter. Let's say it has like 100k, like infinite money. We don't care. It has like infinite money. It can send whatever it wants. The idea of isolation is not that these things can run in parallel. That of course is the idea, but there is a much more deeper understanding to it. The idea here is that let's call this first transaction to, let's make these centers. The first 10k is going to B, the second 10k is going to C. So we will say that let's call this T1. The T1 of 10k is happening between A and B, and then we would say that transaction 2 of 10k is happening between A and C. Now the idea is that if I serialize them there must be one way to serialize them, right? So either T1 happens after T2 or T2 happens after T1, like whatever the case is, like it doesn't really matter. The idea is while these transactions should be able to run in parallel, right? They should be able to run in parallel. you should still be able to write a system that can do this, right? It can say that, okay, if things were to run serial wise, they would run like this, like for T2 first, then T1 first, then T2, then T3, and so on and so forth. So the idea is that even though they are running in parallel, they can be serialized. Okay, that they can be serialized. Okay. Now notice, of course, now this might still feel a bit vague, or it might seem like, okay, what even is the big deal between serialization? The point is that you must remember that there are different conflicts that happen, right? So what happens with the first, like, look at this. So let me explain what has happened here. So here initially they had 11k in the system, right? And then they basically made 2 transactions and ended up with crediting 20k to someone, and they ended up with 1k themselves. Now look at what happened here. So in transaction 1, they read a value of transaction 1. This is what has happened. So they read the value of 11k. Okay, then they sent 10k. Okay, that's what has happened. In transaction 2 also, what has happened is they read 11k and they sent 10k. But if you try to serialize them and try to make like a consistent order of operations, that is not really possible, because how can you read 11k and now the final let's call the read thing a balance instead. So balance was 11k, they sent 10k, balance was 10k, they sent 10k. Let me also erase this line so that I can add another thing. Now final balance b dash will be 1k. Now final b dash will be 1k. Now you try to serialize them. There is no way in any universe where you can try to serialize them in any way, shape or form that will make sense, right? Because that, okay, let me give a counter example, right? So let's consider transaction 3 where you have balance of 5k, you send let's say 2k, and you are left with a balance of 3k. Let's say now you also have a transaction 4 where you have a balance of whatever it is, and you are sending 1k, and you are left with balance of whatever you had minus 1k. Assume something like that, right? I'm not writing the exact values because I want to sort of show something. You can technically run this. Let's assume that the initial balance before starting anything is 5k, right? So let me do that. Yeah, actually that probably will be the better way to demonstrate this. Okay. 5k was the initial value. Now notice what happens here. If I run T3 first, I will be left with 5k as initial balance. I will be left with 3k here. Then if T4 runs, I will be left with 3k as the balance. I will deduct 1k and I'll have 2k, right? That makes sense? That makes sense, right? There is no violation happening here, right? So technically what can happen is T3 can run and then T4 can run. Okay, that means they can run in parallel as well, but they're serializable. That is the idea. Okay, and this is what isolation actually means, that you can run them in parallel, but in reality they can run as a sort of a serial process as well, and no rules would be violated. Now also, just for the sake of argument, let's keep pushing here and I'll show you another thing as well. Now imagine if transaction 4 was the first one to run. So 5k you deduct 1k, you get 4k. Now if 4k was read here, 2k was deducted, you will get 2k as the balance. So T4, T3, that is also possible. Now does that mean that you should be able to perform any permutation and combination and that should be valid? Hell no. At least one serializability thing should be possible. Okay, at least one combination must work, and since we can kind of come up with 2 combination, because I'm being a bit unfair by kind of keeping it as a read write function kind of thing, but you get the idea. I could literally start with anything here. If I was to be stubborn, I could literally say that okay, 5k is read here and then perform the transaction. It is possible. 5k, 2k, you will be left with 3k, you'll get 3k, then 3k minus 1k will become 2k. So there is at least one way to run these 2 transactions in order wise fashion, so one after the other. Therefore they are actually following isolation perfectly. But then look at this moron. How does this make any sense, right? So at one point it read 11k, it performed a 10k deduction, now it has 1k. Okay, now if you try to do 2k transaction 2, the balance is literally 1k. How was it? So it should not have been allowed to read this as 11k, right? So what has happened basically, if you think about it, is that T1 was running. Okay, wait, hold on, let me draw it like this. So T1 started and it was running. While this transaction was going on, T2 started here and it started running. Essentially something like this has happened, which is not allowed. That is very stupid. That should not happen. That is why isolation was broken, because you see how what's happening here, they're interfering, right? There's an interference going on. T2 should have started here, or it should have finished here, like somewhere above, right? Something like that. but it did this. So I hope that this whole example idea kind of makes sense, that these should have been able to, you should have been able to at least form one serial pattern where you can either run T1 first and then T2, or T2 first and then T1, and things should have made sense. But that is not possible here in any way, shape or form, right? As you can see here, there's a read after write kind of a weird nonsense going on. Or maybe I have to just review the serializability thing once, but yeah, you can very clearly see that they're not following the rules, right, of isolation. And that is the reason why also isolation is also a rule that has been broken here. It has been violated. So clearly the answers here are B and C. Right? That's about it. It's a very good question to review because it goes through basically every single thing, and you have to sort of have an idea about what all the four properties really translate to. That's about it. Yeah.